So let's look at example number 4 that deals with the universal law of gravitation. So let's begin. 4 9-kilogram spheres are located at the corners of a square with a side of 1 meter. Now we want to calculate the magnitude of the net force produced on one of the spheres. So let's look at our diagram. We have sphere number 1, number 2, number 3, and number 4, which are placed at the corner of this red square with a side of 1 meter. Let's choose sphere number 1. Since all these guys are equal mass, it doesn't matter which sphere we choose. So let's choose number 1 and let's find all the forces produced on this sphere. So there's a force produced on 1 due to sphere number 2. There's a force produced on sphere 1 due to sphere number 3. And there's a force produced on 1 due to 4 pointing downward. So this one is pointing at 2, this one is pointing at 3, and this one is pointing at 4. Now we want to find the net force produced on this sphere number 1 by all these spheres. So in order to find the net force, we must first find this force, and this force. So let's say that our x-axis is this way. So this is our horizontal axis. And our y-axis is going downward. So this is our horizontal axis. So we basically want to find all the x components and add them up. Find all the y components, add those guys up, and then use that to find our net force. So let's begin by first finding our force due to 2 on 1. So F12. To find F12, we basically have to use the gravitational law, which is g times mass 1 times mass 2 divided by the distance r squared. So in this case, our distance is simply 1 meter, and our masses are equal. They're both 9 kilograms. So we plug in our constant, 6.67 times 10 to the negative 11 meters cubed divided by kilograms times second squared, multiplied by 9 kilograms of mass 1, multiplied by 9 kilograms of mass 2 gives us 81 kilograms, multiply that by our constant, divide that by 1 meter squared, the distance between them. Now note that we're going to assume that these 4 spheres are point masses. So we plug these guys into our calculator and and we find our force to be 5.4027 times 10 to the negative 9 newtons. So this is the force due to this particle, due to this sphere number 2 on sphere number 1. Now let's find this this magnitude, this force by sphere 4 on sphere 1. So force 1, 4. So once again, the same exact story. We use our gravitational law, but now instead of using this distance, we use this distance, which happens to be the same exact distance because we are dealing with a square. And now we change from mass 2 to mass 4 because we're looking at this guy. But our masses are exactly the same. They're identical. So we should get the same exact value, and in fact we do. So 5.4027 times 10 to the negative 9 newtons. Now notice that these two forces have the same magnitude, but they are perpendicular to one another. They point in different direction. One points along the x in the positive direction, one points along the y in the negative direction. So now let's find what the force of this is. What is the force by sphere 3 on object 1 on sphere 1? So notice now we're dealing with this guy. So this force is pointing from this guy along the diagonal across to our sphere 3. And that means this angle is 45 and this angle is 45. So what is the distance between 1 and 3? Well, it's simply the side multiplied by square root of 2. So this distance is the square root of 2. So notice that we want to break this net force down into its x component and its y component. So its x component simply means take the force and multiply it by cosine of the angle, and the y component simply means take the force and multiply it by the sine of that angle. In both cases, angle is simply 45 degrees. So let's find our F on object 1 due to object 3 along the x-axis, which is simply the force going this way. So that means we take this magnitude and multiply it by cosine of the angle. So once again, we use our gravitational law, g times mass 1 times mass 3 divided by the distance between these guys squared, times cosine of the angle. So we simply plug in our values and divide it by the square root of 2 squared, because now we're looking at this distance. We want to find the force or the field created at this point due to this point, this distance apart. So we plug in 6.67 times 10 to the negative 11 times 9, the mass of this guy, times 9, the mass of this guy, times the cosine of the angle between them, angle 45. So we solve this by plugging into the calculator, and we find our force to be 1.91 times 10 to the negative 9 newtons. So this is the force pointing along the x-axis. Now likewise, to find the force due to this guy pointing along the y-axis, we have to simply find this force multiplied by the sine of the angle. So since sine of the angle and cosine of the angle, or cosine 45 equals sine 45, that means we're going to get the same exact value, 1.91 times 10 to the negative 4 newtons, except now it's pointing along the y-axis downward. So now we have all the x components, all the y components. So in order to find my net force of along the x component, I simply add up all my x forces. So I add up this guy, which is pointing in this direction, and I add up the x component due to this guy, and I get 7.31 times 10 to the negative 9 newtons, pointing in this direction. Likewise, to find my net sum along the y-axis, I add force 1.4 plus force 1.3 due to the y component, and I also get 7.31 times 10 to the negative 9 newtons. And now to find my overall net force, I have to use the following formula. The net force is equal to the square root of the squares of the two directions. So the ones going along the x direction and the ones going along the y direction. So I take this guy, plug it into here, take this guy, plug it into here, solve using my calculator, and I find my magnitude of my force to be 1.034 times 10 to the negative 8 newtons. So this is the net force felt by object 1 due to object 2, 3, and 4.